I just finished the Understanding Quantum Computers course from FutureLearn, which is so basically I got to know about this course thanks to Rod via Twitter, because he and a bunch of other people were sharing these. And as I'm following him on Twitter, and I just basically thought I'll give it a try, because one of the things that I really like doing for this channel is going through different learning materials and kind of reviewing them. And I know that, of course, every course I go through sort of influences the way that I see and I experience all the courses. But I thought that would be interesting. It was also my first encounter with FutureLearn as a platform, and I'm going to review in this video these course, but I'm only going to be, because I haven't really upgraded or paid for anything, so I'm just going to be touching the material that is available for free to anyone who actually signs up for FutureLearn. So I definitely do not own any of this stuff, any of the content. I'm not claiming that I do so, and I don't want to really violate any copyright related things in here, but and so I'm going to go through each of the different things. I'm going to go through each of the different maybe lessons and sections and explain sort of my thoughts on that. I have done these. I've gone through all that only on my mobile phone and only during my commutes to work, and that's about half an hour a day. Sometimes I was doing sort of two sessions of half an hour in one day, so a total of 1 hour a day. But it was also really fragmented, right? Because you're in the underground, and other things distract you and stuff. So, but I have to admit, overall, it did a good job, and I think doing it on the phone was not a problem. The course has some interesting, some interactive widgets and some interactive applications, which they all worked pretty well on the phone, on a smartphone. But I guess the experience on the desktop is probably way better, especially in the beginning when you play a bit with waves and stuff like that. I think those widgets are really interesting. Probably, it's a bit sometimes when you need those things in the quizzes, and then you kind of have to go back to the tool to experiment with it. It makes it a bit cumbersome on the phone, but overall it's good. So. First of all, let's set expectations for these. So this course, I'm right at that point in here. So I haven't done the test because it's only available for paid accounts. But the first thing that I have to say is that I think I started this course with a bit of a different expectation in terms of what is it going to be content-wise. But then as I went through week one, I realized that the goal of the course was a bit different than I thought, which is fine. And if that's really the goal here, which is to really give an introduction, an introductory introduction, kind of an overview of the field, and I think that's and I think it does a really good job here. So there's almost no math or nothing that's really difficult to grasp, and which is good for investors, for people in high school, even for myself, who, despite having fun with maths, I really have never spent the time to really, work with maths professionally a lot. So, and I have a computer science background, but anyway, I mean, I can read most of the stuff and, of course, reason and do the exercises and things like that. But it's not. It's not one of my main focuses, and also what I try to do with the Quantum Intuition channel here is to kind of try to intuitively break down concepts and understand things and learn intuitively. What the course has helped me is to kind of basically give me a map of what are the important things in the field. Because when I started the channel, I was a bit lost in doing it sort of a ad hoc by just following the different tutorials from IBM, from the IBM Q experience, and from other companies out there, and then I ended up coming across photonic systems. I ended up coming across, continuous variable quantum computing. D-Wave is sort of where I started with as well. I also did a little bit of quantum error correction before. So and then quantum chemistry is something that I've also dived a little bit into. So I kind of realized that most of the stuff that the course kind of touches as, these are the boundaries of the field, or what's currently kind of known as, areas of interest that are touched by quantum computing. that matches, and I think that kind of helped me as well understand that I basically explored most of the important topics already on the channel, and so that's going to help me sort of to define the next phase for me as well, for the quantum intuition channel. And so this was good, and I think the tone of the course is really cool. The videos are really well done. It definitely helped me glue a lot of the things that I've been playing with, and then I just kind of felt I needed those 2 or 3 sentences where it's like aha, it kind of gives you this aha moment, and so when you go through the what was the quantum chemistry stuff, what was that? Oh, that was week 2 probably, or something like that. No, it was week 3, I think. Other algorithms. Was it? That's definitely not week 4. Anyway, at some point there's a bit of a, so use qubits, entanglement, basic algorithm ideas, state variables. So, but maybe I'll just go week by week and kind of try to recall what was that about, and then kind of what's my impression. Maybe that's the best way to go about it. So, and I haven't. So this course has a couple of interesting ideas also. One of them is that it's accompanied by a YouTube channel that's called Bansu Video Quantum, where basically let me see if I can take you guys there. Home. Yes, no home. So I'll just quickly switch here and bring that up on the tab that I'm recording. So this is it, and then basically Sato is his name. I hope I'm not misspelling names, or that this is really the name. But so those are the main 2 instructors in the course, and basically, so they introduced the channel in the beginning of the course, saying that's sort of an experimental idea where they're playing with daily videos. I thought it was really interesting at the beginning, the concept, but I ended up kind of not watching them. And I'll probably do that anyway, but it didn't feel like super well connected to the course. Like there was no other reference to these videos, almost I would say, throughout the entire course, just at the very beginning. So I think I can easily forget about this, but I can see here weekly feedback. It's like this stuff that is indeed related to the course.
Hi, welcome to week 4 of Understanding Quantum Computers. We hope you're enjoying the course so far. Do different things. Computers. Well, as it turns out, this model, this structure for the crystal, is the same for diamond as it is for crystalline silicon. So, of course, each of these individual atoms are carbon instead of...
Okay, so there's definitely some extra material in here that... Okay, day 15, day 14, it seems like... So I'll probably explore that separately and see if that's something that is interesting or not. But I said weekly feedback. So there's actually feedback sessions.
Somebody asked about the fidelity and about what it represents. So
I wonder if this is really based on an actual question from someone. That would be pretty cool, though.
Fidelity, which we represent usually, be somewhere between 0 of finding what we expect, 100% chance measurement.
Because there's sort of an overall problem with those kind of online courses where, especially with the platform Future Learn, they say, you got 4 weeks of free access, then it's gone. Either you upgrade or it's gone. And so the problem is that I feel the model tries to kind of mimic an actual course where you really go week by week, right? And then apparently those videos really accompany you. It's supposed to, because there's a bunch of, sometimes there's like discussion steps, which I also didn't do, and it's probably bad, but the format encourages you not to do that. It feels a bit, and it's my fault. It's not, it's not really the fault of the way the course is designed, I guess, but it's like you just want to go through the material sometimes. That's just the way that I kind of learn. And so those discussions sometimes have comments in here. Okay, cool. And so maybe those videos are based on some of those comments, and that would kind of make sense. But it just didn't feel like I literally forgot about those videos, and I actually had to even Google the try to find the name of the channel because I couldn't really find it. But basically, so this is one thing. I think it's an interesting concept, but it didn't seem to glue for me completely. But basically, I really recommend this course to anyone who just wants to get a really basic idea of what's quantum computing and sort of what's currently, you know, what is the current scope of research, and later on in week 4 they talk about like funding and business and the industry, and it's really interesting. But this is definitely not something where you're gonna really learn anything concrete about an algorithm. So the first week is about, it's mostly introduction, motivation, and that's really good. And then you do a bit of waves, which is also nice. Sort of a bit of the basic concept of what interference means. But I think in contrast, if you take a look at all the 4 weeks, I think the amount of time and effort spent on introduction and motivation and all this kind of and all this basic stuff is a bit it's a bit disproportionate in comparison to, because it feels between week 2 and 3 there's a huge learning curve. Because then week 2 you go through the qubits, the basics of qubits, measurement, okay, multi-bit states, quantum registers, there's the video, there's entanglement, the basic idea of an algorithm, state variables. So this is to be more technical here. Talk about photons, so about how you really, the different ways of implementing qubits. It's really interesting, but it feels like it takes a while until you really get to. So if you're really interested in one specific topic, the first 2 weeks feel a bit like overwhelming, especially if you have a bit of background already in this. But the course is designed for those who just want to get like a broad understanding of what's in the field, and for that, it's perfect. What else? Week 3. Really, I just feel I'm a bit disorganized, but I just let's go back to week 1. So there's motivation, there's benefits, there's waves, summary of week 1. So the week 1 is. It's pretty okay. It's just interesting. I think it's really interesting to learn about the basics of waves and all that stuff. It just gives you the basic vocabulary. I think that's probably the most important thing, is that this course really gives you the right vocabulary. Actually, there's one piece in week 3 where I'm really thankful because they talk about quantum chemistry at some point, and they really help me to kind of sharpen my understanding of certain words used. Which I had a hard time understanding by myself when I was reading some papers, but we'll come to that. So week 1, week 2, here's more about qubits. So this is really the basics of notation and stuff like that, and then entanglement, decoherence, the basic concept of an algorithm, implementations of qubits, yeah. And week 3 is, I think, probably the most complicated week, because you just right away jump on Grover's algorithm. Now, the interesting part is this Grover's algorithm, background for sure, the classical parts are sure. There's almost no quantum circuit in the entire material, which was a bit. I have mixed feelings about it. Because it's definitely something which is graphical. I don't remember. Maybe there's a couple of them. I really don't remember. But it just, I always thought that those circuits made it a bit more appealing because they're graphical and you kind of can reason about certain stuff. But okay, if you take a look if you just focus on Grover's algorithm and Shor's algorithm, it's probably pointless to just dump one of those circuits, because those are just gigantic or big or just too mathematically abstract if you want to have them compact. So it doesn't make sense. It only makes sense if you but for example, when you talk about entanglement, it's really common to see that circuit where just to create the basic Bell state, where you've got like one qubit here, and then you go into a Hadamard, you apply a Hadamard, and then you apply like a control knot, right? And so these basic understand. I think that's something that is definitely useful. But I mean, it's fine. It feels that entanglement is really discussed from an actual physics perspective, which is actually, probably the best way to go about it, because that's really, what's happening under the hood, right? But um, week 3, so I have to admit that this was probably one of the best introductions to Shor's algorithm, and I wish I had come across that type of introduction before I even dived into the algorithm myself, because that definitely clears a lot of the stuff. Whereas if you just Google by yourself, you're gonna come across a lot of complicated introductions or sort of really confusing ways to get you into the algorithm. It was really good because basically it gives you a bit of background in terms of what is what is it that the algorithm is really doing and trying to do. It makes you spend a little bit of time about discussing about the period concept and stuff like that. You talk about the classical part, and you talk about the actual quantum part. It's a bit heavy, in my opinion, to just dump the quantum Fourier transform in here, but they do this beautifully. I really have to admit that for such a complex topic, for such a complicated topic, this course does an amazing job to give you a really high level understanding of what's happening, and it gives you those keywords, right? Those concepts that you can then go and explore by yourself. So here, it's one I have mixed feelings, because when you read that, right? Of course, I'm a bit biased because I have already done some work in that direction. Sorry, I didn't mean to click here. But I have the impression that if you read through those, if you go through through this material, at the end you really feel probably you don't really understand the algorithm completely. You don't really understand what is the actual algorithm, but then you kind of do understand. So you get a high level understanding of what are the pieces and the bits and pieces you're putting together to really get there. But then the material that is the way it's explained in O'Reilly's book, which is to be more practical for a software developer or someone with a software development background or programming background, that then becomes a bit more tangible and it makes a bit more sense. This is a bit more high level, non-technical introduction, I would say. So I think this non-technicality is really beautifully designed in this course. But if you really expect to get your hands on with code, that's not the place to go. But definitely, it's they do a great job. And here, okay, so there's this bunch of here of about model spectroscopy and eigenvectors. This is definitely so. I think those two videos were really sort of big aha moments for me. I think I really like the analogy of the quantum crash test dummies, as in like quantum computing being the analog of, when you do crash tests for cars, you don't just theoretically analyze how the car is going to behave, but you just go and crash a car, and then you see what happens. So, and the analogy here that Professor James Whitfield does is, it's you basically map your quantum system into a quantum computer, and then you just let the quantum computer go and run. That was really well explained, and then I think for me the biggest highlight of the course was the part of the eigenvectors, because I had been doing a bit of these before by myself, and I even tweeted about it because for me it was still I was having a problem understanding, why we're looking for the lowest energy state in something like VQE or stuff like that. And then I think, I don't know if it's Rod or Professor James, just put it in a really beautiful way, where it's like, eigenvectors and eigenvalues are those elements that do not get affected by a transformation, right? And so the concept maps to the lowest state of energy of a particle, because that state of energy is where there's no movement, because there's no energy, right? And so that's the mapping between eigenvectors and eigenvalues that I was kind of missing a bit to, it's not that it's blocking you from understanding what the algorithm is doing, but it really makes you feel a bit more sure at the holistic level. And so that was really well done. That was a really well done part. Yeah, and then week 4 is basically the hardware part. So the hardware part is really interesting, but it's not what I was here for. But it's nevertheless interesting to kind of take a look at all the different implementations, and then it's really well packaged because it comes then together with quantum error correction, which is a topic that, of course, has to do with the hardware implementation. And I mean, at the stage in which the field is right now, it's definitely really important. By now, since I started the channel around May this year, I know that I'm more interested in the algorithmic part of things, and the software part of things, or the more soft part of things, rather than the hardware. But it's definitely important to know, right, from an architecture perspective. And of course, nowadays, if you want to do something useful, you're really gonna understand what's the architecture of the quantum computer you're gonna run things on. But for the purposes of the channel here, I think it's just interesting. And then the industry part was also just nice. I think most of the stuff I already knew, but it's just a quick view on what's going on in the industry. So it's really overall. I really recommend this course for people that just want to get sort of a holistic view on the field. And really, I think I'm going to leave it here. It's just this is not the course where you're going to get your hands on and kind of build and design one particular algorithm, and kind of get your hands on dirty with more detailed things like phase kickback effect and stuff like that. This is really a high level non-technical introduction. Maybe I'll put it this way. So it's really perfect. Then this, of course, the further study material is really useful. So I definitely recommend checking these in here, because there's definitely a bunch of things you can check out next, and I think that's really helpful. So definitely, thanks to this, I discovered the preprint of the paper, Quantum Algorithm Recommendation for Beginners, which I'm going to use next to kind of break down algorithms on my channel. So there's a bunch of other stuff that I'm super thankful for. Yeah, so I mean, I hope this has been insightful enough. It's definitely doable in 4 weeks. You can even do it faster. You can do it on your phone while commuting. The videos are really well produced and really well from a content perspective as well. I think the combination of video articles and then a bit more sort of the quiz style, it's everything really well put together. It's just you got to have the right expectations for the course. Maybe I don't know if I just didn't read carefully when I went through the introduction or through the sort of understanding what I was getting into, but this is indeed a non-technical introduction to quantum computing. So it's definitely useful for people who want to invest in the field, people who want to, from a business perspective, be able to understand a bit more the benefits of these and kind of stay aware of, what's the BS out there with certain articles about quantum computing destroying cryptography in the world and stuff like that. So it's definitely interesting. So yeah, I think I'll leave it here. If you guys want me to review any other learning material, you can just let me know. I'm going to be basically now reorganizing the channel a little bit in the next days, and I'm probably going to be starting sort of different focus lanes, I would say, on actually breaking down algorithms and doing a bit more of reviewing projects and papers and kind of learning out of that. But I think always going through learning material and then sharing a bit my experience with that, I think it's always helpful for everyone. So I hope you like it, and stay tuned for more stuff coming up on other books as well. Perfect.